BS Busy Research Academy welcomes to you in the lecture number 8. In this lecture, we are going to understand pair sample t-test in the Jamovi. And my name is Dr. Rainbak Sumro and I'm from Shabuti University, Pakistan. Dear friends, this is the interface of the Jamui where you are looking this t-test group. If you open this one, you will find three t-test, three type of the t-test are there. So individual pair sample t-test is a one sample t-test. So my two videos are already available on these two tests and their images you are looking here. In this video lecture, I'm discussing how to compute the pair sample t-test in the Jamovi. So before before doing some work in the Jamovi on the pair sample t-test, I would like to give some concept of the pair sample t-test. Like for example, what is a pair sample t-test? What are the requirements of the pair sample t-test and hypothesis and all these things. So again, I might remind you that there are the three tests are there. All these three tests are basically parametric tests. So whenever we are working with a parametric test, we have to meet some parameters. Okay. So now for this, in order to provide some concepts of the pair sample t-test, I'm opening another link. Okay, so here you're looking Kent State University page. So where some detail is available, conceptual detail is available regarding the one sample t-test, pair sample t-test, and dividend sample t-test. So now we are trying to understand pair sample t-test. So now pair sample t-test compares the means of the two measurements taken from the same individual. So now we basically we are taking the two measurements from the same subject. Now the subject can be can be an individual, can be a object, or in other related unit, the units which are related with each other. So the main thing is here that you are basically we are going to compare the means. These means have been taken at the two different time, but the subject must be same. That means the respondents must be same. For example, there's a one group of the patients. To a group of the patient, you are administering some drugs. So before administering the drugs to the group of the patients, you are computing, you are taking some data from these one, and then you are computing the mean of the data. After administering the drug, you are collecting the data from the same group of the patients, those who have been administered the drug recently. So now the here in this case the respondent should be same. So now after administering a drug, again you are computing the mean. So now then you are comparing the before and after the data which you collected, and then you are computing their mean, and then you are comparing the mean with each other. So this type of the test is called as a paired. As it is clear from the name of the test, paired sample, where you are getting a sample in the like the pairing. Okay, and then a measurement taken in the two different time. Very one important thing is like the pre-test and post-test, and then the measurement taken from the two different conditions, completing a test under a control and condition and experimental, and then come here. So these are the different names of this test: dependent t-test, paired t-test, and the repeated Myers t-test. Okay, so here the dependent variable or test variable is a continuous measured at two different time for two related given conditions or units. Okay, and then common uses are there where in which situation we can use this type of the test where when statistical difference between the between the two time points you want to check statistical difference between the two conditions, and then statistical difference between the two measurements, or if you want to check the statistical difference between the mesh pair. Okay, so now and then if you talk about the data requirements, so now is already I told you that the pair sample test is basically a parametric test. So now there are some assumptions which should be made, like the dependent variable, then it should be continuous. Now continuous can be interval or can be a ratio. Another requirement is a related sample R group. So now in this case, the observation are dependent on each other. In case of independent sample t-test, where the observations were not dependent on each other and observations are what the independent, but in this case, observations are dependent on each other. For example, the subject in each group, sample or group are same. So always the subject or the respondents are same. This means that the subject in the first group and also in the second group. So now the subject should be same, and then the data should be collected randomly from the population. So here the population is the people to whom you are administering a drug, or the students of any class in university to whom you are providing a motivation lecture. Okay, so now population, that is a population, and the data should be normally distributed. That's very important. The difference between pair values is already I told you that the in case of the parametric takes a major assumption, which I believe always that is about normally distributed data. Like it should look like a bell-shaped curve. There should not be significant deviation on the left side or on the left right side, like the left is skewed or right is skewed. And where more importantly, there should not be any outlier. Okay, so hypothesis means that the compared uh, the paired population means are equal and the paired population means are not equal. So these are the two hypotheses are there. Then again, the formula, if you want to calculate manually, then these are the formulas are there. So now we have reached on our Jamovi's interface, and now we are going to apply this test in the Jamovi. So first of all, you have to select the type of the test. So now paired sample t-test, that is selected, and now okay. So first of all, we have to attach the data set with this one. So data set is already available data set for paired sample t-test, which has been attached with our Jamovi. And now, by the way, the link of this data set I have left below this video. If you are like, then you can download it and you can use this data for your practice purpose. And then we have to select the test, pair sample t-test, and then we have to move this one here in. Now, here you are looking, there's some compare, like this is a pair. So if you remind from the sample t-test or independent sample t-test, so now the both like our variable, they were in the like in the parallel line, but these are not in the parallel line, they are like a pair. So now whatever test which you are required, definitely we are interested to apply the t-test over there. And then this is the Wilcoxon tag rank text. You can apply this test when your data is non-normal or when your data is not following any parameters. So now we are not interested right now in this one. So now rest of things are same, and additional step if you want to, that's very important, mean difference, effect size you also check, and then the descriptive and the okay, the multi and QQ So these things have been checked out. So now regarding the results, so paired sample t-test has been applied in this lecture. Before running and after running, these are our two like the samples are there, and this student t statistic, that is about the 4.86. So this is a degrees of freedom. Again, the degrees of freedom can be computed is the n minus 1. Our n is 100 and minus 1, that is become the 99. P value is that means there is a 0.05. So here the p value is much less than 0.05. That means the test is a significant. And then the mean difference is also there, 2.29. So now it means that before running the mean was 11.848, and after running the mean becomes the 9.19. So the difference between these two figures is our 2.29. And then if we go further, so here the course D, and it checks the effect size. Its value is 0.48, and these are the lower and upper bound of this one. Okay, one more important thing is to test the normality of this. So now again the data is non-normal, but this for practice purpose only. So now there is you must make it sure before applying this test the data should be normal. Okay. Then Descriptives of this data set: 100 observations before running and 100 observations after running. Now, again, I want to remind you that the subject should remain same before or after. And the mean is 11.84 and 9.19. Median 11 and 9. Standard deviation you are looking here. Okay, so now how to interpret all these, how to understand? I have developed a one word file. So now we are going over there to understand these results from there. By the way, this table and this table, both I have pasted over here. So these same tables are you are looking here. So now test applied, pair sample test, and then there was a significant difference between the 100 meters running time before 11.48. This is a 11.4 mean, and plus minus 1 point something is there, and after this is the after. So here again, so there's a there's a plus minus 1.1. This like the plus minus difference is there, and training t test the 4.86. This is a 4.86, and then p value is this a p value. So now, and then rule of thumb. So rule of thumb basically is we use this one for the Cohen's d test, which test check the effect of this one. So now 4.486. So now there are the three, we have the categories over rule of thumb to understand the effect of the Cohen's d test. So the first one is our Simard effect. If the value of the Cohen's d, which is right now 4.486, if it is the less than 0.2, it means there is no effect. But if it is the 0.2 to 0.5, then we can say that there's a Simard effect. And then if there's effect of the point from the 0.5 to 0.8, we can say there's a medium effect, and if the effect is higher than 0.8, it is a large effect. So now here this effect falls between the 0.2 to 0.4, 0.5. That means we can say the effect is a Simard effect. Okay, then the hypothesis. There are the two hypotheses. Are there one null and alternate hypothesis? Now we have to decide which we have to accept and which we have to reject. So there is a significant difference between the 100 meters running time before and after training period. That is the null hypothesis. Alternate hypothesis is that there is a significant difference between the 100 meters running time before and after training period. Now, depend on our test. By going through our results which are in this table, we can say that we have to accept the alternative hypothesis. Why? Because the p is significant and there's also difference of the 2.29 between the two mean. So that's why we have to accept the alternate hypothesis because of these proofs, and we have to reject the like the null hypothesis because of these two one. Because null hypothesis says there's no any difference, but actually there's a difference. So that's why we have to accept the alternate hypothesis. Okay, and then decision how to decide. Again, that was a significant average difference between the before and after. So that's true. Now this is significant. This shows significance. On average, the value after running was higher than the before running, 2.29, and then again this is the value of this one. So now this is significant. So now we can say, now our decision, our conclusion is that we have to accept the alternate hypothesis and we have to reject the null hypothesis. So if you want to report this one, this is one pattern to report the results in your paper. Other pattern you want to follow, it's up to you. So now we have reached on our Jamovi again. So I hope that means that you have understood all the detail because regarding the paired sample t-test. Because in this video we have discussed concepts of the paired sample t-test, and practically we have also performed the same test in the Jamovi. So thank you very much for watching this video till end. So now please, you are requested to subscribe my channel, to like this video, to share this video. If you want and have any comment, you can also put your comment below this video. Thank you very much.